Hey friends, Mrs. Joliet here. Today we learned about distributing expressions, so I'm going to model that for you in this video. Make sure to message us though, myself or Mrs. Hall, if you have any questions. So our steps for this are still the same. Number one, check if there's any distribution. Well, this is distributing expressions, so there's going to be. Then distribute first. Box all your variables, circle all your constants, combine like terms, okay? But distributing means mathematically it means something, and then in just the English language it means something. So if I were to distribute a piece of paper to everyone in the class, it means that I would give each individual person their piece of paper. It means to give out to everyone. So when we're talking about the distributive property though, it allows us to multiply a sum by multiplying each addend separately and then adding the products. So I have some examples here. It's a little funky the way they did it, but it still gives us the same idea. So I can do 5 times 8, and I could just say that's 40. Maybe I don't know 5 times 8 off the top of my head, but I do know 5 times 6, and I know 5 times 2. So I can separate 8 into 6 plus 2 because that's equivalent. And I could do 5 times 6, which is 30, and 5 times 2, which is 10, to give me 40. Again, that might be because maybe you don't know 5 times 8 off the top of your head. Or, and I don't like that they chose this summation problem, but that's okay. 4 times 12, I would have broken 12 up into 10 plus 2 because I know 4 times 10 and I know 4 times 2. But they broke it up into 4 times 7 plus 2 plus 3 because 7 plus 2 plus 3 is 12. They multiplied each statement and then added those together to get 48. Okay, that's what the distributive property is. But also, don't forget that just in general, multiplication means groups of. So I'm going to model that with this one. It says 3 times 5x minus 4. When we have a number next to parentheses, that means multiplication. This can also mean 3 groups of 5x minus 4. That's what multiplication tells us. So if I'm doing that group 3 times, I have 5x minus 4, 5x minus 4, and 5x minus 4. I have 3 groups of that. Okay? Need to give myself a little more room. Now I can combine these. I can combine my like terms like I've done before. And they even kind of like line up nicely. If I have 5x, 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 that means altogether I have 15x. Negative 4, negative 4, negative 4. I'm going 4 into the negative, 4 into the negative, 4 into the negative. So that's negative 12. Okay? When we have this distributive property, I'm multiplying what's inside, but remember that multiplication just means groups of. I'm saying I have 3 groups of 5x. I'm saying I have 3 groups of negative 4. That's why the multiplication works, right? I did 3 times 5 is 15x. 3 times negative 4 is negative 12. Okay, but Mrs. Dollier, what if it's a negative? I'm trying to move this down. Stop. There it goes. That means the opposite of 3 groups of 5x minus 4, right? That negative symbol there means opposite. Okay, just like when we were subtracting, it made everything inside the parentheses the opposite. So I'm doing 3 groups of 5x minus 4, but they have the opposite signs. So it's one group of negative 5x plus 4, because they're the opposite. Negative 5x plus 4. Negative 5x plus 4. And that gives me Well, -5, -5, -5, that's negative 15x, and 4, 4, 4 is positive 12. But again, I'm just multiplying. That's why it works. But what I did was take -3, multiply it by 5x. Take -3, multiply it by -4. That's how I get -15x plus 12. But sometimes they're not whole numbers or integers at all. And it's harder to think of a half of a group. Well, no, we can think of half of a group, but a quarter of a group, 3/5 of a group. So I'm still taking this number and multiplying everything in the parentheses by it. So I'm doing 1/2 times 8. Remember, all whole numbers have the imaginary 1 underneath, n. And I'm taking that 1/2, it's a positive, that's why I put the plus sign there, times negative 10, and now I can multiply. All right, different color. So when I multiply fractions, I just multiply straight across. So 1 times 8 is 8, 2 times 1 is 2. So this first one is 8 over 2n plus, oh, remember, I'm just multiplying. Oh, it's a negative. I shouldn't put a plus sign because a positive times a negative is a negative. So, but 1 times 10 is 10, and 2 times 1 is 2. So I have 8 halves, and I have 8 halves m, and 10 halves, okay? That is technically correct. However, it's not simplified. 8 halves and 10 halves can be simplified. I'm going to show that off to the side. So 8 halves, and don't forget it has an m. Even if you do the math over here, you got to bring the m down. Well, 2 can go into both of these. So I'm going to simplify the top and bottom by 2. 8 divided by 2 is 4, and 2 divided by 2 is 1. Oh, that's just 4. So it's 4m, and then I'm going to do the same thing with the 10 halves. 10 halves, 2 can go into both of them again. I'm going to divide both by 2, top and bottom. And I get 10 divided by 2 is 5. 2 divided by 2 is 1. And it's a negative. Don't forget that negative symbol. Negative. Come on. 5. Also, fun fact, when you just multiply by a half, you're finding half of the number. But I really wanted to show that multiplication of the fraction just in case it's not a half. Maybe it's a fourth. Maybe it's 3/5. But we can do this. I didn't box and circle any of these because I only had one variable and one constant, so I couldn't simplify any further. But if I had had more in there, I would box and circle and then start to simplify that. And if you don't know how to do that, go back to the video adding and subtracting expressions to help you with it, okay? But watch the video again, even if you're confused. Look for Khan Academy videos. Send me a one-on-one message asking a question. Help yourself try to figure this out, guys. You got this. All right, bye.